So, hello everyone, my name is Akshay and welcome back to a GFG POTD streak of day 141 with a yet another question which has a name at yet another query problem. So, the tags present here prefix sum, arrays, and what and all just is an algorithm. So, let us see what the today's question is about and we will think of different approaches and let's code it. So, let us read. It's a medium category question. So, you are given n elements and with num queries. In each query, you are given three numbers L, R, and K, where you have to tell how many indexes are there between L and R such that the frequency of A of I from I to n minus 1 is K. Okay, that's question was very simple to understand. Let us see. So it's a zero based indexing and the elements are given, uh, the n is given, the num is given, the array elements and the queries are given, right? So let us understand that how the input and output is coming, and then we will think that how the approaches should be, right? So what we can do here is that we have the elements as 1, 1, 3, 4, and 3, which has the indexes as 0, 1, 2, 3, 4, right? Now what we have to do, we have been given in a query of, let's say, L equals to 0, the R is equals to 2, and K is equals to 2. So what I need to find is from 0 to 2, that is 0 from 2, the elements are these three, 1, 1, and 3, right? So for each and every element, from indexes, from its index, that is I, to n minus 1, if the occurrence of this element, in this range from I to n minus 1, it's K, then you need to do count plus plus. So you need to find all the number of those elements, right? So let us do that. So if I'm at this point, then I can see from this from this point onwards to the last, the number of elements, the number of this frequency of this element 1 is 2, right? Because 1 is here and 1 is here, so it will be 2, and the case was given as 2, right? So we have been incremented our counter by 1. Similarly, let's check for this second element, right? From 0 to 2 we have to check for all the elements, but if you check the frequency of 1 within this range now, that is from I to n minus 1 given by the question, it is just 1, right? The frequency of 1 in this range, you can see just 1. So, and the k is given 2, so we will not increase any pointer. Now for r equals to 2, that is 3, right? And the constraint is that we have to check in the range of I to n minus 1, so we will check in this range. So how, and we have to check for the element itself, that is A of I. So the frequency of 3, that is frequency of AI, that is equals to 3, it's 2 in this range, right? And k is given equals to 2, k is given as 2, so we will do increment one more counter, that is 1 plus 1, that is gives us 2. And this answer was coming from this one and this index, and this index, right? So that is the reason we have this 2 here. Similarly for 0, 2, and 1, that is from 0 to 2 you have to check. Let us write the elements again, 1, 1, 3, 4, 3. That is from 0 to 2 you have to check that how many elements have been repeating just once. So if you look at this element, it is repeating twice. If you look at this element, it is repeating how many times? From here to here it is repeating once. Similarly for 3 it's repeating 2 from I to n minus 1. Similarly for 4 it is 1, and 3 it's 1. So I need to check for 0 to 2, 0 to 2 that is this range. So 0 to 2, how many k is equals to 1 are there? So it's only 1, right? So for the second query, that is 0 to 1, the answer is 1. That is how the answer is 1, right? For the third query from 0 to 4, right, the indexes are here, 0, 1, 2, 3, 4. That is from 0 to 4, count the number of elements have the frequency as 2. So let us count from 0 to 4, which has all the elements as frequency 2. So you can see 2 is here and 2 is here, so that's why your answer is 2 again, right? So the brute force technique is, if you have understand now the input and output, if you were not able to understand while you read your question, so now pause this video and try to think of the brute force approach, right? So let us resume. The brute force approach will be nothing but the things which we were doing while I was explaining you the dry run, right? So we need a for loop to run inside the query, right? Then we need a for loop to run for each and every element inclusive range of L to R, right? For L to R, I need to check frequency of each element in 0 to n minus 1, right? Right? Yeah, this will be the nested three for loops. As soon as if I check the frequency is equals to k, then I will increment my answer, let's say answer plus plus, and I will add it in my array list. Since the return type is array list, so I will keep on adding this answer here, right? For each and every query. So you can definitely see that this is an n cube time complexity, since there is 3 loop, that is O of q into, let us read the constraint, that what are the constraint of L and R. So q is 10 power 3, n is 10 power 3, and A of I is 10 power 5. Okay, So the worst for the L of R will be like for each and every query they have asked me to go from 0 to n. So it will be 2 into q is nothing but 10 power 3. So let us assume at n. Similarly, L to R will be the maximum as n. And last, we have to check the frequency of each and every element in the nth array. So it will be n cube. And n is given as 10 power 3. So it is giving us 10 power 9. So if you are able to code this solution, although our approach is right, then it will give you TLE. So highly recommend you to pause the video here because it's a very basic code. I will not show you the live coding. I'll just pause my video here and I'll code it myself and I will show you. Meanwhile, you also try it, right? So I hope you were able to code the solution. So that's the thing. The first for loop that for each and every query we are iterating. Then the second for loop for the range in which the query was given. The third for loop that is counting for the frequency of each and every element, and we have maintained a count 0 for each and every element before we count the frequency. And if this condition satisfy that the elements which we are counting the frequency and when it is occurring in our while are traversing the array, so do the count plus plus, and if it count is equals to the given key, then do the answer global answer plus plus and add this answer in your array list, right? So let us compile and run and we will see that the TLE comes or not. It will definitely come. Let us verify that and then we'll move on with the optimized approach. So yeah, you get the TLE. The compilation itself was not able to run, right? So before the submission itself, you can verify that, right? So that is it. And if you are, and that's the thinking you should have while you are sitting for an interview, because he or she, the interviewer, will expect you to tell this approach first and then you go to the optimization. So and I've seen that there are many videos on the YouTube that do not start like this, right? So that they just let you go to the optimized approach. So okay, so that's their choice. So let us move on to with the optimized approach as well. So what were the things that was repeating here, that we were always for the L to R range, after we were checking a third for loop, which was always for each and every element we were checking the frequency, right? So that was the repetitive task we were doing. So suppose if we are able to maintain this array, an array sort of thing, which will just tell you in O of 1 that what's the frequency of the element, right? As you can see, if you are able to maintain this array for 1 from I to 1 minus, you can see the frequency is 2 similarly. So if I would have just able to do this trick and I can retrieve this in O of 1, right? So how we can do that? So again, I'll recommend you to pause the video here, try to think of a solution, try to think of the optimized approach, and then you will continue the video again, right? Okay, so I hope you were able to derive the solution, and if not, so let me give you one more hint. So okay, so we have to maintain a 2D matrix, right, in which the row will represent the index of the element and the column will represent the frequency of the element that is represented by the ith row, and this frequency should be should be the frequency of the element in the range from 0 to n, that is in the all array elements, in all elements, right? Now pause this video again for maybe 1 to 2 minutes and try to make this 2D matrix, right? Okay, so I have made the 2D matrix and let's start filling it. So what we have to do is that we need to find the frequency of each and every element from its index to n minus 1, right? What were the elements given to me was that 1, 3, 1, 1, 3, 4 and 3. The indexes were 0, 1, 2, 3, 4. If you look at it manually, right, if you look at this point of element, then what's the frequency of 1 from the point itself and to the last? So its frequency is 2, right? So I will store it as 2. Similarly for this one, it will be 1. For this 3, from the point itself to the last, the frequency of 3 will be 2. Similarly for the 4, it will be 1. For 3, it will be 1, right? What I need to do is now that I will use the indexes of the element which was present, that is the row. The row is representing the elements, right? So I will use that as the first index, and then this frequency element, right? Because the column represents the frequency, and the frequency which you get is the this array 2 1 2 1 2 2 1 1, right? So 0 of 2 will be pointed to 2. Similarly, this will be pointed to 1 of 1, right? This will be pointed to 2 of 2, and this will be pointed to 3 of 1, right? And this will be pointed to 4 of 1. And in each and every 2D indexes, you just have to do plus plus. Why plus plus? I will show you. Let's fill up the matrix and then I will explain you that why we did that. So if we fill it now, it will be 0 to 2, that is 1, right? Similarly, Similarly, 1 and 1 will be incremented. Similarly, 2 of 2 will be incremented. The 3 of 1 will be incremented, and 4 of 1 will be incremented, right? So what this thing shows is that for this for this ith row, which is 0, so for the 0th row we represents the element a of 0, that is 1, right? That is 1. So for the first element, the number, the frequency of the element from the position itself to the last is 2, right? And that's why we mark this entry as 1. We are just marking it entry as 1, right? Similarly, for you can see for the second row, which represents the second element, so the frequency of the second element from the point itself, I'm talking about this one, frequency of second element from the point itself to the last is 1, right? So let's mark that entry as 1. So the first element has the frequency 1, mark that cell as 1. Similarly we did for everything, right? So we know that the cell which is now having 1 represents what, right? But so what should we do? What should we do so that we can directly get from 0 to 3 how many elements are there with the frequency k, right? Now I will recommend you again to pause this video here and think of something in the approach of prefix sum. Can you do something like that? And then resume the video in maybe 5 to 6 minutes. I will do the same thing and then I will explain you. So yes, you were right. If you're able to think of in the context of prefix sum, the tags was also given of this question as prefix sum. So what are we going to do is that we keep on, we know, first of all, we know that this row just represents the first element. The second row represents just the information of the second element. The third row represents the information of the third element, right? So if we add all the rows column wise, right, what I'm saying is that if we add this column as a prefix sum, then can we say that that let's say this third row, the entry which will have, it will say for the from the 0th row to the second row. Can I say that, right? Let's do that and then we will see that we can say it or not. So let's fill it column wise and we'll do the prefix something, right? So initially it is where there is nothing written, that is 0, right? So we will start from this, from the second row, right? And we will fill it column wise. So previously it was 0, right? Prefix sum is nothing but we will take the previous values and we'll do plus. So we take the previous values and do it will be 0, again 0, and again 0, right? So the previous, again, if you are at this point, the previous value was 0, so it will be updated to 1 plus 0, that is again 1. The prefix sum, if you update it, so previously it's 1 and currently it's 0, so 0 plus 1, it will give you 1. Similarly, 1 will be updated to the current value plus the previous value, that is the above value, it will be 2. Similarly, it will be updated to 3. Similarly, this will be updated to 1, this will be updated to 2, this will be updated to 2 and 2, right? Okay, so now let me explain you. If you are able to guess it, then well and good. Now let me explain you that what the each cell is saying. Okay, so when we talk about this answer of 3, the index 3 of 2, it is saying as 2, right? 3 of 2, it is saying as 2. So it is indicating the first index 3 was representing the row, and row was representing the actual elements. But since we have done the prefix sum, so now the third row will represent the range from 0 to 3, right? Because we have done the prefix sum from 0th row to the last row. So this 3 will now represent the range 0 to 3, right? And the index was representing elements, so 3 will represent the index element of 0 to 3, and this 2, the column index was representing frequency, right? So it means that for the range 0 to 3, the number of elements having frequency 2, as the column says, is 2, right? And how the frequency was calculated, if you remember, from the position itself to n minus 1, we have done it that way. Let us suppose we will code it, so we have done it that way, right? Okay, similarly, and you can verify it as well, that for range 0 to 3, I'm saying the frequency is 2, right? So let us verify. For the range, it is 0 to 3. So how many elements are there which has k equals to 2, which has frequency equals to 2? You can see 2 is here and 2 is here. That is only 2 elements. That is the first element and the third element, right? Right. So we have verified it as well. Similarly, let us verify for the answer of 4 of 1. We can say from 0 to 4, the number of elements having frequency 2 is 2. So we can again see from the 0 to 4, the frequency which has 2 is only 2 elements. That is the first element and the third element, right, with the index 2. So that's it. That's the entire logic, right? And so one last thing that what so it means, like we can deduce this summary, right? So suppose the query is given from 2 to 3 and you need the frequency as 2, right? But we know that from 0 to 3 we know it, right? So and from 0 to 1 we know it, right? So if we subtract it, right, till r you wanted, so I taken from 0 to r, and from 2 I wanted, right? So I minus the value from 0 to l minus 1, right? If we subtract it, then we'll get our answer, and we can retrieve this in just o of 1, right? The answer array we made, the answer 2D array we made, we can just write it here, the 3. And what is the frequency that you want? It's k, right? So let us 2 here, and minus, I will do answer of, so it was 2, but I went for 1, right? Because we wanted to include the this lth range, this lth value also in my answer. So I will say answer of 1, and the frequency is k, that is 2. So whatever be the value will be here, right? Answer of 3 to 2, what's the answer? 3 to 2, it's it's 2, and 1 to 2, it's 1. So it will be 2 minus 1 and 1. And if we verify it as well, so the number of elements in the range, in the range, in the index range 2 to 3, so how many elements are there which have the frequency? When you can see there is only one element which has frequency equals to 2, that is the second index. So it is verified as well. Now I highly recommend you guys, I have given you the entire intuition, the entire matrix, how it is getting filled. I highly recommend you guys to pause the video here, give yourself maybe 7 to 8 minutes, or try a dry running a test case as yourself, and try to code it, right? Then we will do the code. So I will explain you the code in the editor section wise, right? So that we can use our time in the most efficient manner, because everything need not to be live coded as of now, right? So let us resume in maybe 2 to 3 minutes. No, not in 10 minutes. Give your time 10 minutes, and then we will resume. So I have given you a skeleton that at which point you need to include which step. So you have to. The first thing was that we were first filling the array with this yellow entries, right? That for each and every element we were counting the frequency, and we were storing one at the frequency cell, right? The cell which has the just the cell which have the value equals to frequency, right? So let us do that thing first, and then we'll proceed ahead. So here goes the first section. I used one for loop. I initialize the count equals to 0, and I use the nested for loop that for each and every element I'm counting the frequency, right? And I'm storing 1 in that particular cell which has the value as the frequency, right? So that indicates me that this is the frequency of the first element for the first row, which from the point itself to the last, right? Okay, so we have now placed all this yellow entries in our 2D array. Let us do the prefix sum now. Prefix sum is nothing but we are we are summing all the columns, right? Each and every column, each and every cell is having the value itself and just the above value. So let us code that step as well, and then we will proceed ahead. Okay, so I have coded that step as well. So for each and every row I'm iterating, that is for I equals to 1 to I less than n, right? Because I need from each and every cell I need the above exact cell to get the answer, right? So that is why I'm iterating for row 1, because from the row 0 there is no above cell present from row 0, right? So that is why I'm iterating from row equals to 1. Then I'm iterating for each and every column, and I'm saying that I of j is nothing but I minus 1 of j. I minus 1 nothing but go just above it and take the answer from there, right? Let us go to the last step, that is iterate for the queries. Let us store the L, R and K, and then we will decide it. So what should be the next step? So suppose if the range is given to you as, let's say 0 to 3, let's say this range, uh, yes, so let's say you are given with this thing, that the L is 0, R is 3, and the K is 2, right? Then you can directly return this thing from 0 to 3, implies that you just have to replace your first index as R, right? And K is given, so just replace the K is frequency, right? So replace it with the column, and that's you will get the answer, right? So in case for the L is 0, then you just have to return what? The answer of R and K, right? But suppose the L is not 0, L and R is not 0, then what should you return? I have already explained you. Let me write it in terms of L and R. So it would be answer of R and K minus answer of L minus 1 and K, right? This should return. So let us code the last step as well. Give yourself 1 to 2 minutes and then resume the video. Okay. Okay, so I have mentioned the last step as well. We are iterating for each and every queries which has the size of num. Now I am storing the L, R, and K values, and I already explained you these two if statements that in deep manner that what is happening here, right, in this 2D matrix. Okay, so let us analyze the time complexity before we hit the submit button. So we can see there is only two nested for loop here that goes for n and n. So that is n square, and then again we are using prefix sum to fill the array, so it will be again n square, but that is parallel work, so n square plus n square. And then the last for loop is for the queries, right? That is for O of q, and in O of q there is only two if statement, and each if is just accessing the index of a 2D array, that is O of 1, right? So it will be 2n square plus n, so the overall time complexity will be n square. And the optimization we did here, that the repeating steps that we were doing to find the frequency each and every time in the brute force technique, we have optimized that in O of 1 by doing some pre-processing using a auxiliary space of O of n square. So this is a time space trade-off. So that is it. Now the overall time complexity has been reduced to n square, that is 10 power 3 into 10 power 3, that is 10 power 6, which is definitely less than 10 power 8. Let us compile and run, and if our output and expected output matches, which is matching, so we will hit the submit button finally to just make sure that everything is on the right page. So okay, great. Our code has been successfully submitted, and we discussed two approaches. Let us give me you a summary. That the first approach was n cube with a space with O of 1, I guess. Yeah, we did not do any pre-processing. And the second approach was of n square, and we use an n square to compute the frequency of each and every element uh, before, and we to compute the frequency of each and every element, and we use this n square 2D array in O of 1 to just access the index and utilize in the n square, right? So that is it for today's video, right? I hope you were able to bear with me till this long, and today I have not forgot to plug in my mic, so I hope today's sound will be much clearer. Okay, so that is it. That is for the last initiative. That's this Java code in the left hand side, right hand side, which I just explained you step by step, and that's the C++ code on the right hand side. It should not be any language should not be any problem for any users, and so C++ users may be able to understand it more well, the vector and all everything, right? So that is it. Let us end this video, and before ending it video, this is my DSL repository. You can start and fork to get it with the source code, and I can already see there are 23,013 folks. That's great. And that's my Instagram channel I especially made for you guys. You can connect to me here as well as on LinkedIn for any doubts and guidance if you may have. And again, I can see that many of you are getting connected with the doubts regarding your DSA journey as well as other doubts as well. So yeah, you can connect me here for anything. And let us meet in the tomorrow's videos of day 142, I guess. So keep practicing, keep learning, do not break your streak. Let's meet tomorrow. Till then, keep learning, keep growing. Bye bye, and take care.